In this video, we're going to learn about modeling whole numbers. Now, in everyday life, we use the base 10 place value system. In this system, the value of a digit depends on its position or place in a number. And as a quick side note, digits are symbols used to represent numbers. The symbols used for the base 10 system are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. The combinations of these symbols will represent some number with a specific value. The number 537 has a different value than the number 735. Even though they use the same digits, their value is different because of the different placement of the 3 and the 7 and the 5. Now, if we take a look at money, it gives us a familiar model of place value. Let's pretend we have some money in our wallet. We have 3 $100 bills, 7 $10 bills, and 4 $1 bills. Now we can take a look at this picture. How much money do we have in this wallet? First, we need to find the total value of each kind of bill, and then we'll add them together to find the total. So we have 3 $100 bills. Adding that together, we get $300. We have 7 $10 bills. If we add those together, we get $70. And we have 4 $1 bills, which add up to $4. Now, if we were to add the total, we would get 374. And we can see how each digit represents a different value because of its placement in this number. That 3 represents 300. 7 represents 70 because it's in the tens place. And 4 represents 4 ones because it's in the ones position. Now we can use base 10 blocks to provide another way to model place value. The blocks can be used to represent hundreds, tens, and ones. Notice that the tens rod is made up of 10 ones, and the hundreds square is made up of 10 tens, or 100 ones. So we have a single block represents 1, a rod represents 10, a square represents 100. Model the number 138 using these base 10 blocks. So looking at each place value or position in this number, if we look at the digit 1, it's in the hundreds position. So that means we have 100. Now we're using a big square block to represent 100. So we have one of those. If we look to the next digit, there's a 3, and it's in the tens position, which means we have 3 tens. So we can use 3 rods to represent 3 tens. Then we look at the digit 8, and it's in the ones position. So that means we're going to have 8 single blocks. Now we can move on to additional examples of where we're going to use these base 10 blocks to help model numbers. So we're going to take a look at this first problem. Let's count hundreds blocks first. We can count 5 of those. So we have 5 100 blocks. If we count the rods, we have 1, 2, 3, 4, 5, 6 tens. So we have 6 tens, and then a single block, 1 block. So we have 5 hundreds, 6 tens, 1 1. We can add those together, or just place the digit in its respective position. We'll have a 5 in the hundreds place, a 6 in the tens, and 1 in the ones position. So our number is 561. Looking at this next problem, we have 3 100 blocks. We have 1, 2, 3, 4, 5, 6, 7, 8 tens blocks, and 4 single blocks. So let's go ahead and put in the digits in the correct position. 3 100s. That means we're going to have the digit 3 in the hundreds place. Since we have 8 tens, we're going to have the digit 8 in the tens position. And then for the ones, we have 4 ones, so we'll have a 4 in the ones position. So our final number would be 384. And for our last problem, we see here that we have 6 100 blocks and 2 rods, or 2 tens, and no ones. We have 6 100s, so we can put a 6 in the hundreds position. We have 2 tens, put a 2 in the tens position, and we notice we have 0 ones. We don't have any. We need to put a 0 in the ones position so that it holds its place value. Well, that's it for this video. Thank you for watching, and I'll see you in the next one.